In today's lesson, we're going to go over some basic geometry definitions. These basic definitions you'll be using the rest of the year. That's why this whole first chapter is stuff that you're going to be using the rest of the class. In your first definition, you already know, a point. When have we dealt with points before? Right here. That's a point, right? A point is an exact location in space, as I've put here. Points have no size. And let me give you a demonstration of why points have no size. Some of you might have done this before. If I tell you to graph the point 3, 2, and you go over 3, and you go up 2, and you put a dot there. Points don't have size. Okay, keep that in mind. And then I ask you next to graph the points 3.5, 2. That's going to be tough, isn't it? A point is an exact location in space. So when you're doing points, if I did too big of a point, you can take the same treat these the same way here. If you do too big of a point, that's not an exact location. We use a dot because that's about the smallest thing we could use to represent a point. But what if I got an exact location here and an exact location here? Well, you just covered it with that single point. Okay, a point is an exact location in space. It has no size. Okay, a spot, a dot. Sometimes, again, when we're talking about Cartesian coordinate systems, we label points with what's called an ordered pair. And the last thing we're going to talk about points is how we name them. Well, that's not how you spell it. We name points with a capital letter. We can call it point P, point Q, point R, point S, point T, capital letters. That's how we name points. A line. You can kind of think of a line as a collection of points. Again, back in coordinate geometry, when you graph a line, x, y axis, you plot a line. A line is a collection of points. It's millions and millions and millions of points that lie along that. That's actually, when you did this in algebra, it was all the solutions to a certain equation. Y equals 2x plus 3 is kind of what that looks like there. It's all the solutions to that equation. It's all the ordered pairs or all the points that satisfy that equation. So a line is a collection of points. But here's what's special about it. A line is a straight path that has no thickness. Got to be careful there too. The same way that a point has no size, really a line doesn't either. A line has no thickness and extends forever in 2 directions. A straight path that extends forever in 2 directions. We name lines with 2 points that are on the line. Or we could use a small cursive letter sometimes. So this line, and watch how I do this. This could be line AB, and we draw a line over the top of it. So we could call that line AB. We could call this line BC. Sometimes they actually write the word and say line AC. It doesn't matter the order. That could also be line BA. It could be line CB or line CA. There's several different ways to name this line. Sometimes, like I said, they'll put like a cursive letter at the end of it, and they'll say something like line L. So several different ways to name lines. While we're on lines, let's talk about this word right here, collinear. Somebody give me some words that start with co. Because I want to know, what does that prefix co mean in English? What does co mean? Be thinking about that. What are some words that start with the prefix co? Take those words: co-worker, co-captain, cohort, And kind of consistent, kind of goes along with the same lines. But the prefix co means with or together. The prefix co means with or together. So if 2 points, that's what's collinear. If 2 points are collinear, where are they together at? A, B, and C here are collinear because they lie where? Together on the same line. If 2 points are collinear or 3 points are collinear, they are simply on the same line. They're with each other on that line. That's all collinear is. Okay? Make sure you know the word collinear. Collinear means they exist together on the same line. Next up, planes. Not airplanes, planes. A plane is a flat surface. Notice again, no thickness. A plane is a flat surface that has no thickness, that extends forever in, it says all directions, but I'm going to go with 4 different directions. North, south, east, west in this case. Because it doesn't extend out from the board, so I really don't like that in all directions. A plane is a flat surface that extends forever in its 4 directions, I guess you could say. A good representation of a plane, I guess, would be a floor. But the only problem with that, well, number one, floors have thickness. And they kind of stop, don't they? If I took this floor and extended it forever in all directions, it would be a plane. If I took the walls, okay, no thickness, extended it forever in 4 different directions, it would be a plane. But planes in football. Anybody tell me where a plane is located? Because you always hear them say that crossing the plane. Y'all heard them say that, right? There's a plane in football. Where's it located? And it'll bother you too because it's not a true plane either. End zone. Before you score a touchdown in football, you got your pylons. Here's your football knowledge of the day. Here's your goal line. You have your pylons at the corner of the goal line. This is out of bounds over here. You can say OB. Out of bounds. And the rule is, if it doesn't matter, if you're to score a touchdown, it says you have to cross the imaginary plane of the goal line. So you have to go across that goal line. The ball must cross the imaginary. So what happens if you dive out of bounds and the ball goes over here, goes outside the pylon? Is that a touchdown? No. Has to cross what they call is a plane. But honestly, now if you jump 10 foot in the air and jumped over the goal line, is that a touchdown? Yeah. If you dug a hole under the goal line and you went underground across no, I would say that'd probably be down. So is it a true plane? Not really. Because in order to be a plane, it would need to extend forever in all 4 of these directions. You have out of bounds. You have a ground. Now it does extend forever in upwards direction. So technically it's not truly a plane. But you see what I'm getting at. A plane extends forever in all 4 different directions. So they're on the right track, at least we're using mathematical terms in football. It kind of makes me feel good. So here you see a plane. It's got points A, B, and C in the plane. By the way, those 3 points are coplanar. You have collinear, you also have coplanar. Points that lie together inside a plane are coplanar. We name a plane with any 3 non-collinear points that are in the plane. And we actually threw in that collinear word along with our plane here. So this could be plane, and they usually just write out the word. This is plane ABC. This is not plane AB. This is not plane BC. It's plane ABC. Has to be 3, and I'll show you why in just a second. Sometimes they use capital cursive letters. They could also call this, if I had an R up there in the corner, they could call it plane capital cursive R. Plane A, B, C, or plane R. Okay, now here's the why. If I'm going to name this, well, let's start out with a single letter. If I'm going to name this plane A, I need you to know which plane I'm talking about. A plane is a flat surface, extends forever in 4 directions. And if I give you a single point, let's say this point right here, that the board that I've got, the screen here, has this point A in it. And I'm going to say this screen is plane A. Imagine this screen goes forever in all directions. Plane A. Is that the only plane that contains that point? See if you can picture this. A plane that's coming at the board. A flat surface, an imaginary flat surface that's actually coming at the board in this direction. Would it also not contain point A? What about one that came in at an angle? Could I not also have one up here that contained point A? If I give you a single point, there are infinite planes that pass through that point. There's not just one. And I need you to know which plane I'm talking about. It's not the board. Well, now, what if I give you 2 points? What if I said AB? Then is there only one plane that passes through those 2 points? No. You've got the board. You've got this horizontal plane that comes at the board that passes through it. You've got a plane here that passes through it. And think, when I say plane, think about a sheet of paper, a really, really big sheet of paper. Okay? You've got the sheet of paper that you could put on the screen, or you got millions of other sheets of paper. So you could go in at any angle. But look what happens as soon as I add that 3rd point. Could you take a giant sheet of paper and pass through all 3 of those points without it passing or being on the board? That's the only one, isn't it? The one that's flat with the board would be the only plane that passes through all 3 of those points. You couldn't run one horizontal anymore because it would pass through these 2, but it wouldn't go through this one as well. So that's the reason you need 3. And here's the reason that all 3 need to be non-collinear. Take away C and put in D. Now you've got the same problem again. You've got infinite numbers. You've got the board, and you've also got the ones coming at the board that would also pass through all 3 of those. So they need to be all 3 non-collinear. So any questions about planes? And then you have space. And we're kind of, I don't know if you've noticed this, we're kind of stepping up dimensions each time. Lines are 1-dimensional. They go left, right. Planes are 2-dimensional. They're flat. They go left, right, up, down. They go in 4 directions, or actually 2 directions, north, south, and east and west. Space is 3-dimensional. The set of all possible points. Not just all points in a flat plane, but all points in a plane, above a plane, below a plane, all points anywhere. And you just see millions and millions of points here. It's made up of infinite planes. If you took millions and millions of planes and just stacked one plane on top of another plane, you've got space. Okay? And it is 3-dimensional. Definitions. A line segment. A line segment is part of a line consisting of 2 points and all the points in between. Those 2 points on the end are called endpoints. Remember that points have no thickness, they have no size. So part of a line consisting of 2 points and all the points in between, there's a line segment. It's part of a line. And again, the endpoints are the ending points. Line segments are named the same way lines are. We could call this line segment AB. Notice I just don't put a line over it. I put a segment. So if you don't have the arrows on the end, it's not a line. It's a line segment. Or I could call this line segment BA. Next we have rays. A ray is also a part of a line, but the difference is it starts at an end point. It only has one end point and extends forever in one direction. This one starts at A, goes through B, and keeps going. This one actually starts at B, and it goes through A and keeps going. So naming these is important. How we name these is very important. Notice I put rays over the top now. Ray AB and ray BA are not the same ray. Because look, these two are not the same rays, right? This one goes in one direction. This one goes in the opposite direction. These would actually be called opposite rays. Don't have to know that. I just threw that on there to let you know. These are opposite rays because they point in opposite direction. Now, a ray later on in math, we'll talk about vectors. Rays and vectors are kind of the same type thing. So what do you think about this? The first one or the second one, which one would be ray AB? What do y'all think? Good job. Second one. Ray AB starts at A, goes through B. Ray BA starts at B and goes through A. Let me ask you another question about rays. Let me draw another one. And you do see how we name rays. Again, 2 points. Would ray RS be the same thing as ray RT? Ray RS starts at R, goes through S, continues going forever. Ray RT starts at R, goes through T, goes forever. Are those 2 rays the exact same ray? Yes. Is RS the same thing as ST? Ray RS starts at R, goes through S, extends forever. Ray ST starts at S, goes through T, extends forever. Are those the same ray? No. Okay, so you do have to be careful about what points you are using. I would say that ray RT would be slightly larger, slightly longer, not larger, slightly longer than ray RS. Your first postulates. What is a postulate? Here's another definition. I'm going to define it in my own way. A postulate is pretty much a common sense statement. How do we know it's true? Guys, it just is. That's a postulate. A postulate is something we know is true just because we know it's true. It just makes sense. So that's what a postulate is. And here are your first 3 postulates. The first one states, and you don't have to write these down. Okay, you do not have to write these down. Just know they're true. Why do we not have to write them down? Because they are. There, common sense. If I give you 2 points, there you go. There's your 2 points. And I say draw a line. How many lines can you draw through those 2 points? How many different lines can you draw through those 2 points? Point. That's your first postulate. Through any 2 points, there is exactly 1 line. Now, through any 2 points. What about through any 1 point? If I say draw a line, if I give each and every one of you this point, and I say draw a line through, will everybody draw the same line? No. If I give you these 2 points, will everybody draw the same line? Yes. That's the reason when you're graphing y equals 2x plus 3 in algebra, how many points do you have to have? 2. How many points does Mr. Green want you to have? 3 or 4, right? But you only needed 2, because if you have 2 points, that's the only line that's going through it. Your second one, through any 3 non-collinear points. We talked about this a while ago. If you have 3 points and they are non-collinear, there is only 1 plane that can pass through those 3 points. If you have 3 points and they are collinear, there's an infinite number of planes. And the last one says, if 2 points line a plane. Hey, look, the board's a plane, right? Or kind of like a plane. And if I draw 2 points on them, and it says, then the line containing those points, guess what? It's also going to be in the plane. If 2 points are in a plane, then the line containing those 2 points are also in the plane. How do we know that? Common sense. We don't have to have some proof of it. We just know it's true just because. Okay, here we go. An angle. An angle is, let's see, by definition, it can be 2 rays, 2 line segments. You don't have to write the definition down. 2 lines that share a common endpoint. Here we have 2 line segments. Looks like, or like I said, it could be 2 rays that share a common endpoint, and we call that common endpoint a vertex. The corner. Okay, the corner of an angle is its vertex. Naming these things, extremely important on how you name this. This angle that you see, the big angle, is either angle CBA we could call it angle ABC. We cannot call it angle CAB. We cannot call it angle ACB. Vertex must be in the middle. The vertex has to be in the middle. Here's why. I like to give you the whys. Which, by the way, angles could also be named with numbers. Like here, this small angle here is angle 1, the small angle here is angle 2. And here's what I want to do. You have a triangle. I'm going to call this angle 1, angle 2, and angle 3. And I'm also going to label it with letters, A, B, and C. Sometimes you don't have to use 3 letters. Sometimes you can use 1. And I say, okay, I want you to take angle ABC in that triangle. Look at it. Everybody's looking at angle ABC in this triangle. Well, if order is not important, couldn't this be angle ABC? Couldn't this be angle ABC? And well, actually, if order wasn't important, all 3 could be angle ABC. But order is important. When you're looking at an angle, angle A to B to C. ABC would be that angle. It's the same thing as angle 3. What about, y'all help me with this, angle, let me call somebody, I'm calling y'all this. Jackie, angle CAB. Angle CAB, would that be angle 1, 2, or 3? 1. So I get that. Which one did I do a while ago? ABC? No, let's do it. Carson, what's ABC? Which angle, 1, 2, or 3? 3. Good job. And finally, Ethan, BCA. That would be angle. BCA would be 2. B to C to A. So order is important. Make sure that you put your vertex in the middle. But naming an angle, you can either use 3 letters, you can use numbers, or when you're done, let's look at this. What if I just call this angle C? Would you know which one I'm talking about? Yeah, angle 2, angle C, same thing. But you can't always do that. Here's a scenario when you can't. Let's say that this is A, B, C, and D. If I say angle ABD, everybody knows that I'm talking about ABD, I'm talking about this angle right here, right? If I said angle DBC, everybody knows D to B to C, I'm talking about this angle. But what if I just said angle B? We don't know which one. Angle B could be this angle, it could be this angle over here, or it could be this straight angle. Okay, so sometimes you can, like here, if you're given just a triangle. Angle B, yeah, that's that one. We know which one. But sometimes if they share the common vertex, you can't just call it angle B. Okay, last thing we're going to do with angles, and you might already know this. If you know this, don't write it down. Let's talk real quick about good note taking. When you're taking notes for not just math class, when you're taking notes for any class, and your teacher says that grass is green, don't write that down. When you get to college and you get to higher levels of your education, you're not going to have time to write down everything that is said in the class, and that's okay. That's not bad. If you already know what an acute, right, obtuse, and straight angle is, don't write it down. Okay. Anything that I say or do in this class, any problem that I'm working, if you're a master at linear equations, you didn't have to write any of that down. Right? Write down what you need to know that you didn't already know. So the 4 types of angles, if you didn't already know this, the 4 types of angles. You have acute angles. Acute angles are bigger than 0, less than 90 degrees. They're small. You have a right angle, which is exactly 90 degrees. And most of the time we'll put a little box in there to let you know it's a right angle. We have bigger than right, which is obtuse, which is between 90 and 180. And then you have a straight angle, which is exactly 180. Those are the 4 types of angles, and you've probably done that for several years. So if you already know it, you don't have to write it down. Okay, let's bring all that stuff together now. And let's try, it says identify all points, lines, line segment, rays, and angles. I think that's all of our different definitions we got. We've all got them all now. Identify all the points. Well, let's not do all of them. Nicole, just give me any point that's on this figure. Point P. And there's how you would write it. Point P, or you could write out the word. And that's enough points, right? Point P, point Q, point R, point S, point O. That's all the points. And you can either do it like a dot with a P, or you can write out the word. Hunter, give me a line. Hunter's not here. Kyle, give me a line. Line RS. You do RS and you would draw a line over the top, or you could actually write out line RS. Question. Kirsty, is line RS the same thing as line OS? Yes. Yes, good job. Next up, give me a line segment, Vanessa. Give me a line segment. Any line segments.
I can't see.
I'm sorry.
No.
Okay. So we have line segment PO. And to write a line segment, you'd put your letters with a segment over the top. Or some people, again, just write out the words line segment PO. So RS, you said a while ago, RS is the same thing as OS. Now, question here is line segment PO, Abby, the same thing as line segment OQ? Because line PO and line OQ would be the same line. But is line segment PO and line segment OQ the same line segments? Did I say Abby? Yeah. Segments. Is this segment the same as that segment? It's not, is it? So you got to be careful with segments. They are the same line, but they're not the same line segment because a segment just goes from here to here. And then OQ would just go from here to here. So not the same line segments. Two completely different ones. Rays. And I'll do the rest of them for you. A ray starts at a point and goes through a letter. So we could say ray OS starts at O, goes through S, keeps going. Ray RS would be another ray. Somebody tell me, are those the same rays? Is OS and RS the same ray? OS starts at O, goes through S. RS starts at R, goes through S. RS is slightly longer than OS, so no, that would not be the same rays. And then angles, again, we're just talking about how to write these. You could say angle POS is one angle. Angle SOQ is another angle. Could also be called QOS. Doesn't matter. Some of you might just want to put them in alphabetical order. You can't, right? You got to make sure the O's in the middle. Is POQ an angle? And if so, what kind of angle is it? Somebody said it, I think. Straight. POQ is an angle. It's a straight angle. It measures exactly 180 degrees. Do this one. We'll do a few more slides and then we'll stop here one more time. This one, which of these can be measured? And think about this. We measure length or distance with rulers, tape measures, yardsticks, meter sticks. That's how we measure distance. We measure angles with protractors. Everybody knows what a protractor looks like, right? Let me see if I can find one. Math tools. There we go. We measure angles with protractors. Okay, how slanted an angle is. So we use rulers and protractors. But I want to know which of these can be measured. Can a point be measured? Let's see what you think. Cindy, could a point be measured? No. Points have no size. I told you that. Zoe, could a line be really careful with this one? Could a line be measured? Okay. Where would you start? Because, and I know why you said this. I know why you said yes. But lines extend how long? Forever. Right? So how big would that tape measure need to be? Pretty large, right? So since lines extend forever in both directions, and we use the word line wrong, don't we? Because, is that a line? Would say, yeah, it's a line. That's not a line. That's a line segment. That's part of the line. Lines go forever. So can a line be measured? Nope. Can a line segment be measured? Yes. Yeah, we can measure from point A to point B. We can measure line segments, but we cannot measure line. Can you measure a ray? What do you think, Kayla? Can a ray be measured? Nope. Goes forever in one direction. Can a plane be measured? No. Can we measure an angle? Yep, use one of those. Okay, we measure angles in degrees. And later on, we actually, same way you have Celsius and Fahrenheit for temperature, probably know this, you've always measured angles in degrees. You also have another unit of measure that we talk about in Algebra 2 called the radian. You have either a degree or a radian to measure angles. These. Okay, the first set of problems here says find the length of line segment, and this one's DC. And notice there's no line over it. If they're talking about the length, a lot of times they won't put the line. But if we're looking for the length of DC, there's C and D. D is at 4.5, C is at 2. How are we going to find the length? It's a number line, and we're looking for how far is it from 2 over to 4.5. What do you do with those two numbers? Thank you. Subtract. 4.5 minus 2 gives you a length of 2.5. From 2 over to 4.5 is a length of 2.5 EL. The distance from E, which is at -4, up to F, which is at -1. You can subtract again if you like. But the only problem is you might get a negative when you subtract. -4 minus -1 gives me a -3. Distance is never negative. So not only do you subtract, but if you want to throw in this word, you would actually take the absolute value as well. Make it positive, pretty much. Subtract and make it positive. Or just look, how far is it from 1 to 4? Right? That's a distance of 3. So to find the distance between 2 points on a number line, you would simply subtract those numbers. On these, it says use the number line to find the ratios. Okay, now I'm trying to pull in that old stuff. Now we're trying to talk again about ratios. The ratio is a comparison. Ratio of boys and girls could be 1 to 3, but that does not mean there's 1 boy and 3 girls. Okay, that's the comparison between the two using numbers. The ratio of AB to CD. AB to CD. Here's AB. Here's CD. Jordan, how far is it from A to B? Good. And how far is it from C to B? Good. So the ratio of AB to CD is 2 to 3, or 2 to 3, or 2 to 3. Do the second one. Jason? We're wanting to know what is the ratio of BD to CF. BD to CF. Let me mark those for you. BD is there. And CF, here's C, is there. JC, B is at 2 and D is at 9. What's that distance? Good. And JC, C is at 6 and F is at 13. What's that distance? So the ratio is 7, 7, or you could put, it's a 1-to-1 ratio. What does a 1-to-1 ratio mean? They're both the same. Anytime you hear those words, 1-to-1 ratio, the first is the same as the second. Now, does that mean that both distances are 1? No, it means that both distances are the same. It could be possibly 2 and 2, possibly 3 and 3. We studied about ratios the other day. Okay. Last thing we're doing today, congruent segments. Lines cannot be congruent. Lines go forever. We're not talking about congruent lines. We're talking about congruent line segments. And we'll also go ahead and knock angles out while we're at it. These are called tick marks. Called tick marks. Anytime, and you already know this moment, anytime that you want to show somebody that 2 line segments are the same, and when I say same, the same distance, use tick marks. In this drawing, EL, line segment EF has a single tick mark. Line segment HF has 2 tick marks. Are they the same? No. No. In order for 2 line segments to be the same, they're going to have the same number of tick marks. So in this drawing, in this type drawing here, I could make the statement that segment EF is congruent to, and you need to know that symbol. An equal sign with a little squiggly mark over the top of it, or a tilde, I think is what that's called. An equal sign with a tilde means congruent. So in this kite, EF is congruent to, somebody finish up for me, please. GF. EF is congruent to GF. Is EF also congruent to FG? GF, FG, it doesn't matter order, okay? With line segments, it doesn't matter which one you put first, which one you put second. So EF and GF are congruent, and again, in order for them to be congruent, I guess we could say this. In order for these to be congruent, that's a symbol for congruent, this must be true. And a lot of people are confused by that. Shapes are congruent. Shapes are not equal. You're going to want to say that all year. Shapes are not equal. EF, line segment EF is not equal to line segment FG. What's equal about them? Their measurements. The line segments are congruent. Anytime you just see EF, that means the distance from E to F. EF is equal to GF. Segments are congruent, their distances are equal. You could go on a step further, you could say, well, HF, I don't see anything with 2 tick marks, but I do know that ED, line segment, is congruent to DG. You can put DG or GD because they also have equal measurements. With angles, and like I said, we're going to go ahead and knock this out while we're on it. With angles, they do it a little bit different. There's 2 different ways to show that angles are equal. This is one way. Notice they drew an arc, little arc in each of these, and they put a tick mark on, 1 tick mark, or they could have done 2 tick marks on each of them. That means that angle ELH is congruent to, we'll put it down here below, angle what? GFH. Another way that sometimes they do that, they'll do this. Instead of drawing an arc and putting 2 tick marks and drawing an arc and putting 2 tick marks, sometimes they'll just put the same number of arcs. That's another way you might see it. It might have just 2 arcs. Or both of them might have 1, 2, 3 arcs. 1, 2, 3 arcs. That also means that they're equal. Obviously, these 2 would not be equal. They have a different number of arcs. Okay? So